Welcome, ladies and gentlemen, to another edition of Binary Life. And today we'll be treating a 7Q kata entitled hammingDistance binary codes. So instead of reading all of this, you can read it yourself. It's on the screen, but the exercise is pretty simple. We are given two strings like this. All of them is going to be in binary. And fortunately for us, they are going to have the same length. So we have to get the hammingDistance. What is the hammingDistance? Is how many characters are different in both strings in the same position. For example, let's take the second one. Here the first letter is 1, and in the other string the first letter is instead 0, so they are different at position at the 0 index, if you wish. They are also different at the first index 1. They are different at each of the 4 indexes. That's why we have the answer is 4. And here the answer is 2 because they're different at index 2 and 3. They're different at that point, and the same at every other index. Basically, that's it. So the best way to solve, luckily, like I said, they have the same length. So the best way to solve is to choose any one of them, get the length. It's gonna be the same as the length of the other one, and then loop through the string, loop through one string, and as you're looping through every index, you check to the other index if the value at that point is the same. What do I mean? First of all, I'm going to create a count variable that's going to be counting the number of differences. So we initialize it to 0, and then I'm going to connect the length. Let's just call it the length. Let's just call it the string length. String length is gonna be equal to, I'll pick the length of any one, something like that. Right. So I'm going to make a for loop that loops from 0 right up to the length. And what are we going to do? We're going to be checking the indexes of the character at so basically this I here is these are indices. So we are going to be looping through the string, one index after the other. That's why we start at 0 up to the length, and we're going to do that simultaneously on both strings and collect where the characters are different. So if the character of A at this specific index I is different from that of B at the same index, then we have to increase our count. That's it. At the end of the day, we're going to get the number of hammingDistances. So we can return count. So I can attempt. We seem to have an error. Okay, here the for loop. So it's I. Let's test again. We pass the test, and let's attempt. I think we've passed the whole test. Now I can just reduce this and put it directly there and get rid of this line. That's it. Right, and let's run again, and this is the algorithm. I will just submit so that we can see if there's any difference from other people's solution, if there are alternative approaches to this, and see how we can learn one or two things. This is the same thing we've done here. This is a split, and he filters. This is crazy. He splits one of the strings. I don't think I get it. He filters one of the strings and loops over every character. The looping variable is n, and I is the index, and it checks if n, the nth character of this A array, because now it's an array now. So the nth character equal to the bth character at that specific index I. That's it. So he filters where they are different, and it's going to return the array of the differences, and he just gets the length. Yeah, this is kind of a wise one too. Right, but the concept remains the same anyway. Yep, this is the same like this one up here. So this is crazy. Whatever algorithm you have seen here, the principle actually remains the same. It's the same approach, just like this first one, which is very easy to read. So I'm going to stop here today, and thanks for viewing, and see you on the next video.